Alright, part 2, chapter 2, module 3, Navy, electrician, Navy module 3, circuit breaker. A circuit breaker is a protection device that, like a fuse, will stop the current in circuit if there is a direct short, excessive current, and excessive heat. Unlike a fuse, a circuit breaker is reusable. The circuit breaker does not have to be replaced, and after it's open and broken, the circuit breaker, instead of replacing the circuit, you can reset it. Circuit breakers can also be used with a circuit control device by manually opening and closing the contacting circuit breaker. You can switch the power on and off the circuit control device. Will be covered in more detail in the next chapter. The circuit breakers are available with a great variety of sizes and types. It would not be possible to describe every type of circuit breakers in use today, but this chapter will describe basic types of circuit breakers and their operational principles. Circuit breakers have 5 main components as shown in Figure 216. The components are the frame, the operating mechanism, the arc extinguishers, and contact terminal contact connectors and tripping elements. Alright, this shows the Figure 216 shows the circuit breaker connectors, the arc extinguishers, the contacts, the trip bar, the terminal connectors, the operating mechanism, molded case frame. The frame provides insulated housing used to mount with the circuit breaker components. Figure 217. The frame determines the physical side of the circuit breaker, maximal allowable voltage and current. Operating mechanism provide the means of opening and closing the breaker contacts, turning in the circuit on and off. The toggle mechanism shown in Figure 217. Quick mate with a quick break type. The means for the contact snaps open close quickly regardless of how fast the handle is moved. Additionally indicating whether the breaker is on and off. The operating mechanism handle indicates if the breaker is openly and automatically tripped and moving in position between on and off. To reset the circuit breaker, the handle must be first moved to the off position, then to the on position. Figure 217 shows the circuit breaker construction, the case frame, terminal mounting screws, line connecting terminal, operating mechanism, arc extinguisher, operating handle, cover, and cover screws. The arc extinguisher divides the extinguisher arc drawn between the contacts of the circuit breaker that interrupts them, and the arc extinguisher is actually a series of contacts that open and gradually dividing the arc, making it easier to confine and extinguish. This is shown in Figure 218. Arc extinguishers generally use in a circuit breaker that control a large amount of power, such as those found in the power distribution panel. Small power circuit breakers, such as those found in lighting panels, may not have arc extinguishers. Figure 218 shows the arc extinguishers. Terminal connectors used to connect the circuit breaker to the power source and the load. The electrical connected with the contact circuit breaker that provides the means with the connecting circuit breaker to the circuit. The trip element is a part of the circuit breaker that, since the overload connection covers the circuit breaker, the tripper breaker. The chapter will cover the thermomagnetic and thermal magnetic used in the most circuit breakers. Some circuit breakers may use a solid state trip. The units may use the current transformer solid state circuitry. Alright, thermal trip element. Thermal trip element circuit breakers use the bimetallic element heated with the load current with the bimetallic element is made with the 4 strips of 2 different metals bonded together. The metals expand at different rates. They are heated to cover the biometallic element to be bent and heated by the current going to the load. Figure 219 shows how they can be used to trip the circuit breaker. Shows element A shows the load, the bimetallic element, the trip bar latch, and contact closed line. Contact B shows the metal heats and bends and opens the contact over the load on an overload. Trip bar latches and contact opens line and bimetal. Figure 219 shows the thermal trip element action. A trip element with a normal current. B contacts open. Alright, Figure 219, View A, shows the trip element with a normal current with a bimetallic element is not heated successfully, does not bend, but the current increase the temperature around the circuit breaker, increase the bimetallic element bends, pushes the gun for the trip bar, releases the hatches, then contacts open, shown Figure 219, View B. The amount of time it takes the bimetallic element to bend and trip the circuit breaker depends on the amount of the element. The heated, large overload will heat the element quickly. A small overload require longer time to trip the circuit breaker. Or magnetic trip element. Magnetic trip element circuit breaker used with the electromagnetic interior of the circuit load is in Figure 220. The normal current with electromagnetic will not have enough attraction to trip the bar to the move of the contact remain closed, as shown in Figure 220. View A, the strength of the magnetic field with the electromagnetic and increase the current with the coil increases. Soon the current in the circuit becomes large enough to trip the bar that is pushed toward the magnetic element. The electromagnetic contacts open and the current stops, as shown in Figure 220B. View B. Figure 228 shows the load and the magnetic element, the trip bar latches and contacts closed in the line. Load shows the load being the magnetic element closed gap open contacts and the contacts open between the line. The amount of the current needed to trip the circuit breaker depends on the size of the gap between the trip bar and the magnetic element. On some circuit breakers, there's a gap and therefore the trip current is adjustable. Thermomagnetic trip element. Thermal trip element circuit breaker is like a delay fuse which protect the circuit against small overloads. Continue for a long time. With large overloads, faster circuit breaker will trip. The thermal element will also protect the circuit breaker against temperature increase. The magnetic circuit breaker will trip instantly with the present current. The present in some applications, most type of the protections are designed rather than two separate circuit breakers. A single trip element combining thermal and magnetic trip elements are used. The thermal magnetic trip element is shown figure 221. 221 show the load magnetic element, the trip bar and contact closed. Show the load also and then contacts open, and then the load and contacts open line. Alright, in thermal magnetic trip element, circuit breaker magnetic element, electromagnets connected to share with the circuit breaker with a metallic element and heated with the load current with a normal circuit current with the metallic element does not bend the magnetic element, does not attract the trip bar shown figure 221 view A. If the temperature of the current increases over a sustained period of time, the biometallic element will be then pushed to the trip bar and released. The last circuit breaker will trip the shown figure 221 view B. If the current solidly rapidly increases enough, magnetic time will attract the trip bar, release. The last circuit breaker will trip the shown figure 221 C. The circuit breaker has been tripped enough that the thermal element has now had no time to react and increase the current. Or your trip-free, non-trip-free circuit breakers. Circuit breakers are classified as being trip-free or non-trip-free. The trip-free circuit breaker is a circuit breaker that will trip open even if the operating mechanism on and off switch is held in the on position. Non-trip-free circuit breaker can be reset and held on if the overload or excessive heat condition is present. In other words, non-trip-free circuit breakers can bypass the holding of the operating mechanism on. Trip-free circuit breakers are used on circuits that can tolerate overload of the non-emergency circuits. Examples of these are precision current-sensitive circuits, non-emergency lightning circuits, non-essential equipment circuits, non-trip-free circuits that are used as for circuits that are essential for the operation. Example of these circuits are emergency lighting, quality control circuits, essential equipment circuits. Your time delay rating. Circuit breakers are like fuses that are rated with the amount of the time delay. The circuit breaker is rated with an instantaneous short delay to long delay time. The delay time of the circuit breaker can be used to provide selective tripping, and use the cause the circuit breaker close to the faulty circuit to the trip. This will remove the power of the faulty circuit without affecting non-faulty circuits. Figure 222 should help you understand selecting trip. Alright, you have the incoming line circuit breaker 1 at 300 amps, circuit breaker 2 at 200 amps, circuit breaker 1 at 100 amps. For the circuit breaker 4, you have 100 amps, circuit breaker 5 at 50 amps, circuit breaker 3, 30 amps, so it should equal to 200 circuit breakers. Notice that the circuit breaker 1 has been divided into 2 circuit breakers, and then the loads of circuit breaker 8 and 9 and 10 equal up to 100 amps, so you have load 5, 6, and 5, 6. Use the circuit breakers and power distribution system. Figure 222 show the proper distribution of the using circuit breaker for the protection circuit breaker. One circuit breaker, the entire circuit for all 7 loads. The circuit breaker 22 feeds the 1, 2, and 3, 4. Circuit breaker 4, 5, and 6, 7. And circuit breaker 3 feeds the 5, 6, and 7. The circuit breaker is 6, 8, 9, and 10. All circuit breakers are rated in the same time delay, and overload of the 5 causes circuit breaker 1 or circuit breaker 3 in circuit breaker 8 to trip. This would remove the power of all 7 loads, even though the load of the 5 was only circuit breaker with an overload. Select the tripping would have circuit breaker 1 rated with a long time delay, with the circuit breaker 2, circuit breaker 3 rated in a short time delay, circuit breaker 4 through 10 rated with instantaneous with the arrangement of load 5 and the overload. Only circuit breaker 8 would trip. Circuit breaker 8 would remove the power of the load before circuit breaker 1 or circuit breaker 3 could react for the overload in a way that only the load would affect the other circuit will continue to operate. Physical types of circuit breakers. All circuit breakers presented for this chapter have been physically large, designed to control large amounts of power, typical with a toggle operating mechanism. Not all circuit breakers are this type. The circuit breaker figure in 23, physical large, control large amounts of power with the 4 operating mechanisms, not toggle, except for the difference operating mechanism. The circuit breaker is identical. Circuit breakers are represented. Alright, show the flexible connection, the arc extinguisher, and your overcurrent trip elements. Circuit breakers use the low power protection such as 28 volts DC or 30 amperes can be physically small with low power UV extinguishers and not required, so not UV the construction of these circuit breakers. Figure 224 shows the low power circuit breaker of the push button push pull type. The circuit breaker has a thermal trip element with a metallic disc and non-trip tree. The push button is operating mechanism of the circuit breaker. Figure 224 shows the push button circuit breaker by metallic disc and contacts and breaker closed, breaker open. You will find other physical type of circuit breakers as you work with electrical circuit. They are found power distribution light panels, even though the individual equipment, regardless of the physical side of the amount of power of the circuit breaker. The basic operation principles create your circuit breakers apply. Magnetic trip element makes you the magnetic element of the electromagnet. It can reach the pressed quantity. Magnetic element attract the trip bar release of the last thermal magnetic trip element combined with the action by metallic magnetic elements in the signal trip element and the bimetal elements. Magnetic elements react. The circuit breaker will trip. Alright, your circuit breaker maintenance. Circuit breaker requires careful inspection, periodic cleaning. Before attempting to work on the circuit breaker, check out the applicable technical manual carefully. When you work on the chipboard circuit with the circuit breaker, the approval of the electrical engineering officer must be obtained before starting the work. Before certain removal of all power circuit breakers. Before you work on tag and switch and remove the power to the circuit breaker to ensure the power is applied while you are not applied while you're working. Once approval has been obtained, the incoming power has been removed. The switch tag, and you have checked with the technical manual. Begin to check with the circuit breaker. Manually operate the circuit breaker several times to be sure operating mechanism works smoothly. Inspect the contacts for pitting of the arc and corrosion, pitting of the present, smoothing contacts of the fine file. Number the 00 sandpaper between the certain contacts make contact with the operating mechanisms on. Check the connection of the terminals to be certain that the terminals wire tight and free of the corrosion. Check all the mounting hardware of the tightness and wear. Check all the components of the wear. Cleanliness of the circuit breaker completely. When you have finished the work with the circuit breaker, restore the power. Remove the tag from the switch to apply the circuit. Alright, Chapter 2 Summary.